Okay, so we got this one down, right? Now, very first question we had was what is the parent function to this one, right? So, this is the reciprocal function, all right? And it has the equation, the parent function is f of x equals 2. It was 1 over, and then we have a, x minus h plus, okay. Well, that's the formula. The parent function for this one is just 1 over x, okay? But when I put these numbers in there, I change the original parent function, okay? So, but like again, if we said this, the f of x equals to 1 over x, it was a function that looked like this. Like that, okay? But like I said, when I add stuff, it changes, okay? So first of all, what kind of transformations are occurring here? We know that h right here is the 3, so this right here is my h, right? So which way is the function moving? 4 units to the, I'm sorry, 3 units to the what? Left, okay? So this one right here is translated, okay? 3 units to the left. That's one thing that's happening. What else is happening? It's translated 2 units which way? Down, because this right here is my k value, right? So that would make it 2 units down, okay? So this one is moving 2 units down. Now I'm answering the very first one. Describe the transformations, okay? Now, it is moving 3 units to the left. It is moving 2 units down. What else is occurring? It's stretch right here. This right here, that's my a value. And an a value is going to be stretched which way? Vertically, right? So this one is stretched 4 units vertically, okay? So stretched 4 units. Is that your stomach? Alright, so stretch 4 units vertically, right? Because it's like that, right? So that's transformations. That's something we did a long time ago, okay? We okay with that? Remind you?
Can we have most of this on the test?
No, there's one question on that. I know we did very well on that. Right now, what we've done recently was we found the vertical and horizontal asymptotes, right? So where are the vertical asymptotes? How do I find that? It's right there. I find my vertical asymptotes. I'm going to erase this part right here. All right. I find my vertical asymptotes right here. This x plus 3 tells me where the graph is moved, right? However, it also tells me where the bottom can be 0, and it can never be 0. So what I do for the vertical asymptote is I set it equal to 0. So I have x plus 3. I set it equal to 0. Okay. All right. So how do I solve that for x? X equals 2. I move the 3 over by subtracting 3. So x equals to negative 3. And that negative 3 is a vertical asymptote, right? So if I draw my graph, say I draw my graph, where is x equal to negative 3 at?
On the right.
It's on the right. Well, negative, it's on the left, right? So I'll be like 1, 2, 3. That's negative 3. So there'd be a vertical line right there, according to this, right? Now, how do I find horizontal asymptotes?
Negative 2.
Well, yeah. Well, what I want to do is, by definition, what we did is we looked at this, right? And that would tell me, because this one is smaller than this one, that there's a horizontal asymptote at y equal to 0, right? However, like Dom said, this function is moved down 2, right? So where is the horizontal asymptote at? Well, it's moved down 2, right? So it's going to be 1, 2, which would be right there. Okay?
So like 2 is?
Yeah, because look, what we did last time, we looked at the asymptotes with just that.
So it'd be
Okay.
1 and 1.
So, what do you mean?
The exponents, right? That's what
Oh, yes, no. When there's not a letter there, okay, there's really, you could say there's an x to the 0 if you wanted to, because x to the 0 is 1, okay? Yeah, go ahead and go. All right, so because it's x to the 0 is just 1, this one is smaller than this one. So basically, if there's nothing there, it's smaller than that one, okay? So this one is smaller. Because it's smaller, that meant that there was a horizontal asymptote of y equal to 0. Okay? But that's the original parent function, right? But then because I'm subtracting 2 on the end, then it moves that asymptote down 2 units. Okay? So therefore, my graph, when I graph it, will look something like this. It'll come down like this, and then it'll go down like that. I'm not going to ask you to graph the function, I don't think, but you have calculators, so you'll be able to graph it. Okay?
We're
That looks
looking
like that.
exactly on the line.
Sorry?
We're not exactly get it on the line. When you tell us to graph it.
Well, get really close. I mean, what you should get exactly correct are your asymptotes. Okay? If the solid graph line doesn't look exactly, okay. Alright? But your asymptotes should be exact. Okay? Because it's kind of obvious. Okay? Now, the domain. How do I find the domain of this function?
What is going on today? Like,
So, what's the domain of the function? What numbers can, well, when we're talking about domain, we're trying to find all the numbers that x can be, right?
It's gonna be, all real numbers except for -3.
Exactly, okay? This right here, the vertical asymptote that I found right here, this basically tells me what the domain cannot be, right? So the domain cannot have -3 in it, right? But what can it have?
Everything else.
-2, -1, 0, anything but this. So my domain for this function is going to be all real numbers except what? Not equal to -3. So it'll be all real numbers except -3. Okay? Are we okay with that? All right, now,
Is there
What?
another way of writing that?
you could write it out the words, all real numbers except -3. Sorry? There's one question, it's a 4-part question, okay? Now, what is the range for this function if I draw it?
It's gonna be all real numbers except for -2.
-2. All real numbers except -2.
Why
Right?
is that?
Because it won't touch -2. It'll get real close, but it won't touch, okay? So the range, we'll put all real numbers, y not equal to -2. Okay? Bless you. Okay?
Bless you.
Now, what do you think the word discontinuities mean?
I don't even know. I was about to ask you.
I don't know. Well, basically, let's break down the word. What does continuous mean?
To
To continue. And does what?
Where it stops.
Where, if it's continuous, it doesn't stop, right?
Yeah.
What if I put discontinuous? It does, or it's not, it can't happen, right? Do I know where the function cannot happen? Where does it not touch?
3 and 2.
It doesn't touch -3, right? Basically, it's asking what is a vertical asymptote, okay? Because discontinuous means that the denominator is 0, and I can never have a divide by 0. So the discontinuity is just right here on this column right here. The only discontinuity actually is that x equals to -3, okay?
What does that mean?
I mean, it doesn't touch. That's a vertical asymptote. Discontinuous means that if I put a -3 right there, what's -3 plus 3? 0. Can I ever divide by 0? If you put it in your calculator, it's going to say error.
So whatever equals
Okay.
0, that's the.
So, yeah. Well, the discontinuity is directly related to the vertical asymptote.
So like,
Okay?
is it kind of saying like, infinity?
No.
She gave me Cheetos.
Not really, no. Discontinuous means wherever there's an error. If you calculate, if you look in your error, wherever that it says error, there's an error right there.
Oh, okay.
Okay? We okay with that?
So if it asks for discontinuity.
Discontinuities.
Yeah, it'll only be vertical.
Only vertical. Okay, only care about this. Doesn't really care about the horizontal because that's a y. I'm worried about when the denominator is 0. That's a discontinuity. Okay? Not a fancy word for what dividing by 0. Okay? So are we okay with that? That's an answer to the question. That's not multiple choice. You've got to know those words. Okay? Can't just be good at math. You've got to be able to speak your math. Okay? We okay with that?
Yeah.
Good? All right.
What if we spoke math?
Okay, so we got this one down, right? Now, very first question we had was what is the parent function to this one, right? So, this is the reciprocal function, all right? And it has the equation, the parent function is f of x equals 2. It was 1 over, and then we have a, x minus h plus, okay. Well, that's the formula. The parent function for this one is just 1 over x, okay? But when I put these numbers in there, I change the original parent function, okay? So, but like again, if we said this, the f of x equals to 1 over x, it was a function that looked like this, like that, okay? But like I said, when I add stuff, it changes, okay? So first of all, what kind of transformations are